In this video, I'll be going over 5 percentage strength and 5 ratio strength questions in detail, showing you how to solve each of them step by step, and we are starting right now. Hello, this is Dr. Dankwa, and if this is your first time here and you'd like to learn pharmaceutical calculations, tips, tricks, and strategies, then start by subscribing and clicking the bell so you don't miss anything. So this video is great for beginners who are new to the topic of percentage strength and ratio strength and need help understanding those concepts. I'll be breaking down each question and providing clear explanations for each step. So by the end of the video, you have all the tools and knowledge to tackle any percentage strength or ratio strength question with confidence. So let's get right to it. This question says, what is the percentage strength of an injection that contains 50 milligrams of phenobarbital sodium in each milliliter of solution? Round to the nearest whole number. So in this question, the goal is to calculate the percentage strength of the injection. And before we actually solve this question, it's important to recall some essential concepts. Now, when you talk about percentage strength, it's one of the ways of expressing concentration. And concentration is important because it's a way that we're able to describe the amount of solute that will be contained in some definite total quantity of preparation. And so when you have a preparation, you're either going to have a solution, in which case you're likely to have one of two scenarios. The first one being the weight in volume, where your solute is a solid and your solvent will then be a liquid, and so you end up with a solution, so a weight and volume solution. The other scenario you could also encounter for a solution is when you have the volume in volume. So in this instance, your solute is a liquid and your solvent is also a liquid. So your total preparation is a liquid, is a solution, but then you have a volume in volume solution. But what if you had a semi-solid, for example, like an ointment or a paste, in which case your percentage strength will be captured as a weight in weight, because your solute is going to be a solid and your diluent is also going to be a solid. So your total preparation is a solid. So you have a weight and weight preparation. Now, it's important to understand these terms because they become very useful for you to have a clear understanding of what the question is asking. You're able to put it in the right dimension to know how to proceed with your solution. So if you need further explanation or you want to see additional problems on percentage strengths, I'm going to put a link to several of the videos on the channel in the cards, and I'm also going to put it in the description as well. So the first thing we need to be comfortable with are these terms. So the other important concept we want to recall is the notion that concentration is equal to the quantity of solute divided by the quantity of preparation. Now, this is a very powerful equation because it allows us to know when we are solving this type of problems where the numbers go. Do they go in the numerator or in the denominator? And what goes on, in this case, the left-hand side. So once you understand this relationship, you can actually solve all of the problems for percentage strength and ratio strength very easily. So for this particular question, the concentration is actually going to be a percentage strength. So what is a percentage strength? Typically, for a weight and volume, what you have is the quantity in grams out of 100 milliliters. So that's the definition of percentage strength for the weight in volume. So what that will mean is we could set up an elegant proportion that some quantity in grams out of 100 milliliters is going to be equal to the quantity of solute divided by the quantity of preparation. So this is a useful equation to remember. But let's see how you apply this for this particular question. So here, the first thing we need to understand is what kind of situation are we in right now? Is it a weight in volume, a volume in volume, or a weight in weight? Now, sometimes the question actually tells you explicitly, but most of the time you need to infer that from the way the question is phrased. Now here, what you will notice is your solute, which is the phenobarbital sodium, is actually given as 50 milligrams. So this is a solid that you're going to weigh. And because you're going to weigh that and it's a solid, then it's going to be the weight. Now, since it is a solution, then you end up with the weight in volume. So we're going to use the definition, the quantity in grams out of 100 milliliters equal to some quantity of solute divided by the quantity of preparation to solve this particular question. Now, to make things more easier when you want to use this relationship or equation, we want to convert the milligrams to grams because the definition for percentage strength, weight in volume, once again, is some quantity in grams out of 100 milliliters. So let's do that. We have 50 milligrams. We can convert this to grams using the conversion factor that 1,000 milligrams is 1 gram. So the milligrams cancels out and you end up having 0.05 grams. So what we can do is we can still maintain that equation that some quantity in grams divided by 100 milliliters is going to be equal to the quantity of solute over the quantity of preparation. Now here, we need to determine what goes in the numerator and what goes in the denominator. Now since this is a proportion, it's important to make sure that your units match up numerator to numerator. So since the units of grams is in the numerator on the left hand side, it kind of guides you even if you're confused where this value goes. So the 0.05 will go right here. And from the question, it's saying you have this much phenobarbital in each milliliter, so in 1 milliliter. So we can now go ahead and solve for x, which is the unknown. And actually, when we solve for x, that is going to be the percentage strength. So x is going to be equal to 0.05 grams times 100 milliliters divided by 1 milliliter. Now the milliliters cancels out and you end up with 5%. So this question says, if an injection contains 0.5% weight by volume diethiazine hydrochloride, calculate the number of milligrams of the drug in 25 milliliters of injection. Round to the nearest whole number. Do not include units. So in this question, we've been given the percentage strength and we've been given a quantity, the 25 milliliters, and the goal is to calculate the number of milligrams of the drug. So let's break the question down a bit before we proceed with the solution. What it is here is you're actually being asked to find the quantity of the solute. So in the previous question, we talked about how it's important to recall that concentration is equal to quantity of solute divided by quantity of preparation. And we talked about the definition of percentage strength being some quantity in grams divided by 100 milliliters. And that is the definition for the weight and volume scenario. And that's what we have right here, weight and volume. So we can actually set this equal to the right hand side, which is quantity of solute divided by the quantity of preparation. So you can actually just go through this using the proportion very quickly, but I'm breaking it down this way just in case if you needed a process to actually understand where the numbers go, because sometimes I do get the question is how do you know whether the number goes in the numerator or the denominator? And a good way to process that is to understand this particular equation. So once you've got it down, you can actually go through the process without writing out all the terms. But what this will mean then is on the left hand side is where we have the concentration. Our concentration that we are dealing with right now is a percentage strength. So that will go on the left hand side, and 0.5% implies that you have 0.5 grams in 100 milliliters of the preparation. So now that's going to be equal to the quantity of solute divided by the quantity of preparation. Now, because you've been given the 25 milliliters of injection and we understand that it's a weight and volume preparation, then this 25 is actually representative of the total quantity or the quantity of preparation that you have. So the 25 milliliters will go in the numerator. So that is how you will know where the numbers go. Now, the other way you can quickly come to the same conclusion is by aligning the terms to match up with what's on the left-hand side. And that works really nicely for the weight and volume scenario because you have different units in the numerator and the denominator. So because you have grams in the top on the left-hand side and milliliters in the bottom, you want to make sure that the milliliter component is going to be in the bottom. So once again, just to put in there a tip or a trick, when you're dealing with the weight and volume, it's actually easier to know where the terms go because you're going to line them up with the definition of the percentage strength. It's a little bit less obvious when you're doing volume in volume and weight in weight because the units in both the numerator and denominator are going to look similar. Okay, but for weight and volume, it's actually lines up really nicely. So what it means then is by default, we are looking for the term that goes in the numerator here. So we can go ahead and solve for x. And so x is going to be equal to 0.5 grams times 25 milliliters divided by 100 milliliters. Now the milliliters cancels out and you're going to end up with 0.125 grams. But we don't stop there because the question is asking for quantity in milligrams. So we need to proceed with the conversion step and we are going to make the statement that 1 gram is 1,000 milligrams. So you multiply that by the 0.125. The grams cancels out and you end up with 125 milligrams. Now the question says do not include units. Make sure it's a whole number. So the answer is actually 125. This question says how many liters of a 2% weight by volume iodine tincture can be made from 123 grams of iodine? Round to the nearest hundredth. Do not include units. So in the question here, you've been given the percentage strength, which is your concentration, and you've been given the quantity, and the quantity is in grams, and it's 123 grams of iodine. Now the question is asking for some volume in milliliters that can be prepared from the 123 grams of iodine. Now the phrase "can be made from" points us in the direction of the fact that we'll be looking for the total quantity of the preparation. So we want to recall once again that the concentration is going to be given by your quantity of solute divided by the quantity of preparation. And here you have 2%, so that implies you have 2 grams of iodine in every 100 milliliters of the tincture. Now that's going to be equal to the quantity of solute. The question, the quantity of solute is going to be 123 grams, so that goes to the numerator, because first of all is the solute, and also the units need to match up on the left hand side and on the right hand side. So what we're actually looking for is going to be the term in the denominator. So at this point it's going to be some quantity in milliliters. We're going to go ahead and solve for that value. That will give us the volume in milliliters, and we need to obey the instructions in the question and convert that to liters. So now that's going to imply that X is going to be equal to 100 milliliters times 123 grams divided by 2 grams. So the grams is going to cancel out, and you're going to end up with 6,150 milliliters. But here again, the question is asking for volume in liters. So we do a quick conversion using the conversion factor that 1,000 milliliters is 1 liter. So the milliliters are going to cancel out, and you're going to end up with 6.15 liters. Now the question says round to the nearest hundredth. It's already to the nearest hundredth. It also says do not include units. And so the answer is actually going to be 6.15. This question says, how many milligrams of procaine hydrochloride should be used in preparing 120 suppositories, each weighing 2 grams and containing 0.25% weight by weight procaine hydrochloride? Round to the nearest whole number. Do not include units. So here in the question, we've been given the percentage strength. And now here the percentage strength is 0.25% weight by weight. So this is on the weight by weight basis, which means the solute is a solid and the total preparation is also a solid. Now we've also been given some quantity here, which is 2 grams, but that is for 1 suppository, and you have 120 suppositories that you need to prepare. So that implies that to get the total quantity, you need to multiply the 2 grams by the 120. That will give you the total quantity. So now that we've established that that's the total quantity, it means that the question is actually asking for the amount in milligrams of the solute. So we can proceed with our equation that the concentration is equal to the quantity of solute divided by the quantity of preparation. So we're going to determine the quantity of preparation, and the way we're going to do that is to multiply the 2 grams, because it's 2 grams per 1 suppository, and you have 120 suppositories. So you end up with a total of 240 grams. So now we can go back and use the 0.25% weight by weight, because that's what the concentration is. And that would imply that you have 0.25 grams of procaine hydrochloride in 100 grams. So notice the units, unlike the weight in volume where it is grams per 100 milliliters, here you have grams in grams. So it's the quantity in grams out of 100 grams, or it could be the quantity in micrograms out of 100 micrograms. So the units must match up numerator and denominator. And if you need more examples, just check out the other videos on the channel. I'll link a few videos in the cards, and I'll put the links in the description as well. But now this ratio is actually going to be equal to the quantity of solute, which is what we are looking for. So that will be some quantity in grams divided by the quantity of preparation, which we determined to be 240. So the 240 grams goes here in the denominator. So now we can go ahead and solve for X, which is the unknown. So X is going to be equal to 0.25 grams times 240 grams divided by 100 grams. Now the grams cancels out, and that's going to be equal to 0.6 grams. But notice that the question is asking for the answer in milligrams. So we're going to do a quick conversion where 1 gram is 1,000 milligrams. The grams cancels out, and you end up with 600 milligrams. Now the question says round to the nearest whole number. Do not include units. And so the answer is going to be 600. Now this question says how many milliliters of tolu balsam tincture should be used in preparing the following prescription. You have resin of podophyllum, 25% is on the weight by volume basis. You have the tolu balsam tincture, which is 5%, but notice it is on the volume by volume basis. And then your entire preparation is 30 milliliters. The question says round to the nearest 10, do not include units. So let's proceed with the solution. We're going to start off once again with the equation concentration equals the quantity of solute over the quantity of preparation. So now on the left hand side, we have concentration. Now this concentration is actually referring to the 5% volume by volume. So now that would imply that you have 5 milliliters out of 100 milliliters. So 5 milliliters of tolu balsam in every 100 milliliters of the tincture. Now we're going to set this equal to the quantity of solute over the quantity of preparation. So from the question, we know the quantity of preparation to be 30. So the 30 milliliters goes in the denominator here. That would imply that we are looking for the quantity of solute. So we're going to put X as our variable, X milliliters. So now we can go ahead and solve for the unknown, which is X. X is going to be equal to 5 milliliters times 30 milliliters divided by 100 milliliters. The milliliter terms cancel out, and now that's going to be equal to 1.5 milliliters. But notice that the question says round to the nearest 10, do not include units, and so the answer is going to be 1.5. This question says convert a ratio strength of 1:480 weight by volume to a percent strength. Round to the nearest 100, do not include the percent sign. So here we are converting from one way of expressing concentration, which is ratio strength, to another way of expressing concentration, which is the percent strength or percentage strength. So here it's important to recall that when you have a 1:480 preparation, then what that actually implies is that you have 1 gram of your solute in 480 milliliters of the preparation. And so here, to convert to percent strength, you want to set up a very simple, straightforward proportion using the definition of percentage strength. Now, you would recall that the percentage strength definition is some quantity in grams out of 100 milliliters. That is the definition for percentage strength on a weight by volume basis. So if you go ahead and solve for X, which is the unknown, whatever that value is, that's going to be the percentage strength. So let's do that. We go ahead and solve for X. X is going to be equal to 1 gram times 100 milliliters divided by 480 milliliters. The milliliters cancels out. But essentially what you have, even though the answer is in grams, is going to be 0.21%, because per the definition, it's some quantity in grams, which is the 0.21 out of 100 milliliters. That definition is a percentage strength, so you end up with 0.21%. But the question says do not include the percent sign, so the answer is going to be 0.21. This question says an injectable solution contains 2% weight by volume lidocaine hydrochloride and 1:50,000 weight by volume epinephrine. How much of this solution would a patient need for a 50 microgram dose of epinephrine? Round to the nearest 10, do not include units. So in the question, we have two ways of expressing concentration. We have a 2% weight by volume lidocaine hydrochloride. We have 1:50,000 weight by volume epinephrine. Now, since the question is talking about epinephrine, the concentration of interest in solving this question will be the 1:50,000. And the other quantity that we have is the 50 micrograms of epinephrine. And so what the question is actually asking for is how much of the solution. This phrase right here, how much of this solution, actually refers to the total quantity. So that's what the question is asking for. So we can use the equation concentration equals quantity of solute over quantity of preparation. And so we've determined from our analysis of the question that we are looking for this term right here, and the 50 microgram is going to be the quantity of solute. So what we could do is simply put the 1:50,000 on the left hand side of the equation, which would be 1 gram out of 50,000 milliliters, but that would be such a small value. And also, since the quantity of solute is given as 50 micrograms, we could actually take the 1 gram in 50,000 milliliters convert the grams to micrograms so that we have the same units in the numerator, and that will make the computation very, very easy. So we're going to use a conversion factor that 1 gram is essentially 1,000,000 micrograms. And we could actually also take out some of the zeros. So let's just take out all of these 4 zeros. So we're going to take out 4 zeros from the numerator as well. And what you essentially have is 100 microgram over 5 milliliters. So now we have our quantity in micrograms in the numerator, and then a volume term in the denominator in milliliters. And we can set this equal to the quantity of solute, which is 50 micrograms, divided by some quantity in milliliters. So we actually did this process here just to make our computations down here so that the algebra is a little bit more manageable. So we go ahead and solve for x, which is the unknown. So x is going to be equal to 5 milliliters times 50 micrograms divided by 100 micrograms. Now the micrograms cancels out, and you're going to end up with 2.5 milliliters. But notice that the question says round to the nearest tenth, do not include units. And so the answer is going to be 2.5. This question says clonidine hydrochloride is available as an injection with a concentration of 500 micrograms per milliliter. What is this concentration expressed as a ratio strength? Expressed, the answer is 1:xxxx. So it's important to recall once again that ratio strength is actually 1 gram divided by some volume in milliliters. So now that we've established this, it may be strategic to convert the micrograms to grams so that we can simply set whatever that ratio is equal to the 1 gram over x ml and then solve for x. So what that will look like then is we're going to take the 500 micrograms per milliliter, which implies 1 milliliter. We're going to convert the micrograms to grams. So we're going to use a conversion factor that 1,000,000 micrograms is actually 1 gram. So the micrograms will cancel out. And what you end up having essentially is 5 times 10 to the negative 4 grams divided by 1 milliliter. And we can set this equal to 1 gram over x milliliter. So when you solve for the x in the denominator, that's going to be the value on the right hand side of the column. So let's go ahead and do that. So now x is going to be equal to 1 milliliter times 1 gram divided by 5 times 10 to the negative 4 grams. And this ends up being equal to 2,000 milliliters. And so here the ratio strength is actually going to be equal to 1:2,000. This question says, express the concentration of sodium benzoate in this formulation as parts per million. So you have sodium chromoglycate 1 gram, sodium benzoate 0.01 gram. So this is important for solving the question. And then the total quantity of your preparation is 25 grams. That's also an important term that we need to solve this question. So it's important to recall that in this question, the sodium benzoate is actually the solute, and the quantity of solute there is 0.01 grams. And then the total quantity of your preparation is 25 grams. So we can take those two numbers and make the statement that you have 0.01 gram in 25 grams. Quantity of solute over quantity of preparation. And now we can set this equal to some quantity in grams divided by 1,000,000 grams. Now this right hand side here, that is the definition of ppm. Parts per million implies some quantity in grams divided by 1,000,000 grams. Now that's if you're on a weight by weight basis. Now, the way this question is phrased, because your total quantity is in grams and the quantity of your solute is also in grams, you are operating on a weight by weight basis. So what it means here is that when we solve for x, whatever that value is, that is going to be the ppm. So let's go ahead and solve for x, which is the unknown. So that would imply that x is going to be equal to 0.01 grams times 1,000,000 grams divided by 25 grams. The grams cancels out and you end up with 400 parts per million, ppm. This question says, how much of a 1:15 weight by weight mixture of haloperidol decanoate would be needed to supply 2.12 grams of haloperidol decanoate required to prepare a formulation? Round the answer to the nearest tenth. Do not include units. So in this question, we have the ratio strength, which is given on a weight by weight basis, and that value is 1:15. So that's the concentration. We also have been given a quantity, the 2.12 grams. Now this 2.12 grams actually represents the quantity of solute in this preparation. So what we are looking for from the question, or what the question is asking, is to determine the quantity of the preparation. So we're going to essentially be using the equation concentration equals quantity of solute divided by the quantity of preparation. So this concentration is the 1:15, and that would imply that you have 1 gram of haloperidol decanoate in 15 grams of preparation. So we're going to set this equal to the quantity of solute, which from the question is clearly stated as 2.12 grams. So that goes in the numerator, so 2.12 grams divided by some quantity in grams, and that's what we are looking for. When we find the x, that will be the quantity of the preparation, and that will be the answer to the question. So we'll go ahead and solve for x, which is the unknown. X is going to be equal to 15 grams times 2.12 grams divided by 1 gram. The grams cancels out, and you end up with 31.8 grams. But notice the question says round to the nearest 10, do not include units. And so the answer is going to be 31.8. So we just took a look at 10 questions covering percentage strengths and ratio strengths. These were really essentially beginner level type questions. And if you're new at this and you don't have a process already, I just wanted to recommend that you really become strongly familiar with this equation right here. The concentration equals quantity of solute over quantity of preparation. If you have a strong handle of it, you will never get the question wrong because you always know where the numbers go, no matter how the question is actually phrased. So I hope you found this video tutorial useful. If you did, be sure to like it and share it. And if you have any questions, leave them in the comments and I'll get to them as soon as I see them. If you'd like to learn more pharmaceutical calculations, tips, tricks, and strategies, then start by subscribing and clicking the bell so you don't miss anything. Thank you so much for watching, and I'll see you in the next video.